This is Andy Barrett of polyphys.com, introducing an app that allows you to organize concepts in a visual interface. The app is inspired by the mathematical principle of a category. A category is a set of objects connected by morphisms. In the workspace on the right, objects are represented by circles and morphisms by arrows, which connect one or more inputs to one output. The category can also be edited using the code forms on the left. The top form shows the morphism rules, and the bottom form shows the objects and their positions. On the top left, there's a clear button that can be used to clear the workspace and the object positions. When the Apply Code button is pressed, the code in the left panel is used to generate the corresponding workspace diagram. And likewise, the Update Code button will take the workspace diagram and use it to generate the corresponding code. To create an object, we can click anywhere in the workspace, and then we're allowed to type a name. To change the label of an object, just press the Enter key. This will toggle in and out of label mode. You can use the Delete key to remove the selected object. Use the New Morphism button to create a new morphism. You will be asked to select as many inputs as you like, then press Enter. After that, select the output. Each morphism only has one output. Once we've selected the output, a morphism template is created with a corresponding button allowing us to reuse that morphism. The button shows the name of the morphism as well as the number of inputs. If we hit the Update Code button, we see the code corresponding to the morphism we just created, which takes in 2 inputs and gives 1 output. There's some physics to how these objects interact, which can be adjusted using these controls in the bottom left, but that's mainly just for looks, so I'll leave it to you to mess with those. Alternatively, we can add to the category by typing directly into the code window. Here we're free to use whatever we want. We can create new morphisms and new objects. And when we hit Apply Code, the things we typed will be generated in the workspace. Also, be sure to end each line with a semicolon. I don't use a lot of error checking. The category here can be used to represent anything. The objects can be people, places, or things, concepts, numbers. What I like to use it for and what I originally made it for was to study equations and the relationships between the quantities in physical equations. So as an example, I'm going to construct a category for the equations from Newtonian mechanics. So these are all the objects that I wanted to consider, but now let me construct the morphisms, or the relationships between them. Okay, so this is what I've ended up with. There are 4 morphisms used to relate 10 objects. For this sort of thing, the fewer morphisms, the better. Once I've gotten to this stage, I'll look for symmetries in the morphism structure. Those may indicate that there are quantities that I've left out, or they may indicate that I need to remove a quantity to make sense of what's left over. In this case, force is highly connected, and that adds to the asymmetry of the structure. So I'll take force out altogether and we'll see what we have left over. Now I can try to symmetrize this graph the best I can. I do this by noting that k and u are symmetric with respect to the operation between them, the addition operator. Thus, seeing that there's this morphism structure that leads to k, I might think that there's an analogous structure that leads to u, composed of analogous objects. It's then an exercise in creativity to imagine what these objects are. So in this case, just as kinetic energy has mass and velocity, I would expect potential energy to have 2 analogous quantities. Let's call them A and B. And they should have these properties such that A times B squared equals U, and A times B is a quantity analogous to momentum. So let me build this out a little bit. So in this case, I used charge and 1 over r as analogies for mass and velocity. Then the analog of momentum is something that goes like q over r, charge per distance. And I might then think that the derivative of this with respect to time gives something analogous to force. Well, that's it for now. Go to polyphys.com to play with this app and all the other apps that I've made. And if you enjoy my work, then please consider making a contribution so this project can continue to grow big and strong.